It's another great learning day, learners. This is Teacher Marisol, and I am your science teacher for today. Join me as we discover fun and challenging adventures in learning grade 9 science. Last week, you learned about how the quantum mechanical model of the atom describes energies and positions of the electrons. Today, you'll be learning on the different types of compounds based on their properties such as melting point, hardness, polarity, electrical, and thermal conductivity. I am here to help you learn more about the lesson. Our topic is taken from the most essential learning competency of the Department of Education about recognize the different types of compounds based on their properties such as melting point, polarity, hardness, electrical, and thermal conductivity. As learners, you are expected to
determine the types of chemical bond present in a compound and identify the properties of chemical compounds.
So, what are you waiting for? Grab your pen, paper, and self-learning modules, and let's begin the next episode of an exciting journey in learning science. Are you ready? Let's go! Have you ever seen salt and white sugar side by side without any labels? How do you differentiate one from the other?
There is a wide variety of compounds, and most of these look physically the same, like table salt and white sugar. It would be easier to determine these substances by tasting them. However, this method of identifying substances does not apply to other compounds, since some of them can be toxic.
Let us now refer to the PowerPoint presentation that will help you understand the activity. Let's roll!
Compounds are formed between the chemical combinations of two or more separate elements. There are two common types of compounds based on their chemical bonding characteristics: ionic compounds and covalent compounds. To distinguish between the types of compounds, it is important to take note of the type of elements that are chemically combined. An ionic compound is formed from the combination of metal and non-metal element. On the other hand, a covalent compound is formed from the combination of two non-metal elements, or a metalloid and a non-metal element. To determine an element, if metal, non-metal, and metalloid, you can refer to their location in the periodic table. The squares colored blue are the metals, the yellow ones are the non-metals, and the red ones are the metalloids. As you can see, most elements are metals and are placed on the left side of the periodic table, except for hydrogen. On the right side are the non-metals, separated by a stair-like pattern of elements, which are the metalloids or semi-metals. Ionic compounds are formed between a metal and a non-metal. The chemical combination between the two elements results in the formation of ionic bonds between the atoms. Now, let's move on to covalent compounds. Covalent compounds are substances that are formed from the chemical combination of two or more non-metallic elements. This could be between a non-metal and another non-metal, or non-metal and a metalloid. Atoms of the different elements are held together in molecules by covalent bonds. Unlike ionic bonds, where electrons are completely transferred from one atom to another, covalent bonds share their valence electrons.
Like all other compounds, substances formed by these types of compounds are necessary in our daily living. Here are some examples of common ionic compounds and their uses.
Sodium hydroxide is used as a cleaning agent. It is used in the manufacture of soap and detergents. Calcium fluoride helps prevent tooth decay. This is a component of toothpaste.
Now, let's look at some examples of common covalent compounds and their uses.
Water. It is one of the most important substances on Earth. It is essential to life processes, daily and domestic use. Our body needs water. It helps maintain bodily functions and regulate body temperature. In addition, water plays an important role in the balance of the ecosystem. Carbon dioxide is used as a refrigerant in fire extinguishers. It is also an essential gas for plant and animal processes like photosynthesis and respiration. However, too much of this gas in the atmosphere is unsafe because it contributes to global warming. When table salt and white sugar are placed side by side, they are physically the same when looked at because they're both white crystalline solids. We all know that table salt tastes salty, while sugar tastes sweet. These properties clearly tell us that they are very different substances.
Aside from their taste, how are salt and sugar different? More specifically, how are ionic and covalent bonds differ from each other?
Ionic compounds have very high melting and boiling points. The force of attraction that holds the negative and positive ions together is very strong. The more ions there are in a crystal structure, the stronger the ionic bond. Therefore, these compounds require a high temperature to melt and boil. Ceramics, which are made of ionic compounds, are an effective heat-resistant material suitable for cookware.
Now, learners, take a look at the picture presented on your screen. What do you think is the property of compound being described? Great! Hardness. Do you think ionic compounds conduct electricity in aqueous solution?
Ionic compounds can conduct electricity when dissolved in water to form an aqueous solution. They separate into ions which can carry electricity in a solution. These ionic substances that conduct electricity are referred as electrolytes. When an ionic compound like salt is dissolved in water, the ions break out individually into cations and anions. These ions are then free to move. When the electrodes are dipped into the salt solution, the cations flow into the negative electrodes, while the anions flow into the positive electrodes, causing electricity to flow.
Are ionic compounds non-conductors of electricity in solid form? Good job!
Solid ionic compounds do not conduct electricity. Instead, they are good insulators.
Are ionic compounds soluble in water? Yes, ionic compounds dissolve well in water. Now, let's move on to the properties of covalent compound.
The covalent bonds between atoms are quite strong, but the intermolecular forces and the attraction between molecules are relatively weak. The addition of a small amount of energy separates these molecules easily. Therefore, they have low melting and boiling point.
Are covalent compounds as hard as ionic compounds? You got it! The answer is no.
Because of the weak attraction between the molecules, covalent compounds, in general, are soft and easy to break, which causes molecular compounds to form gases, liquids, and soft solids at room temperature. Covalent compounds tend to be more flammable than ionic compounds.
Can covalent compounds conduct electricity?
Covalent compounds cannot conduct electricity because the molecules of the compounds do not separate into ions. Thus, they cannot carry electricity in the solution. Covalent compounds can be polar or non-polar. The polarity of the molecules results from the differences in the electronegativity of the bonded atoms. Electronegativity is the ability of an atom in a molecule to attract shared electrons toward it. The greater the electronegativity of an atom, the stronger is its ability to attract shared electrons towards itself and away from the less electronegative atom. Covalent compounds do not conduct electricity in liquid state.
Are covalent compounds soluble in water?
Covalent compounds do not dissolve well in water.
Now you're learning! Here are some enrichment activities for you to work on to strengthen the basic concepts you have learned from our mini lessons. Take a look at the PowerPoint presentation on your screen.
Activity 1. Write the letter I if the given statement describes an ionic compound and property, and the letter C if it is covalent.
This time, let us see if you got it right. Catch a glimpse on the listed answers. See? You're doing great! You're learning! Alright, now, let me ask you these questions. What is the importance of chemical bonding in chemistry and in our life? Nice! 3 types of chemical bonds are important in human physiology because they hold substances together that are used by the body for critical aspects, such as energy production and homeostasis. These are
Ionic bonds, covalent bonds, and hydrogen bonds.
Why are covalent bonds so important in nature? Correct! Covalent bonds are the strongest bonds in nature.
This is due to the even sharing of electrons between the bonded atoms, and as with anything equally shared, there is no conflict to weaken the arrangement.
Oh, I know you are all learning great today. To heighten your understanding on our lesson today, try to answer the next activity. Alright, I guess you're done. Take a look at the screen if you got the correct answers. Did you get a high score? Very good! Congratulations! I think you learned well today. People can have strong connections. Similarly, some atoms can also have strong bonds between them. The oxygen we breathe is a result of chemical bond. The carbohydrates we eat, the proteins we need, the things we use are all result of chemical bonding between atoms. The gas we use in our car is a result of chemical bonding too. Always remember that all the atoms and other particles and cells in the body are held together by ionic and covalent bonds, and these bonds connect everything together on a cellular level. That's all for now, so stay tuned and see you on our next video. Read your modules carefully and answer the questions appropriately. Always remember to contact your teachers for you to keep updated. Once again, this has been your teacher broadcaster Maricel G. Estrosas saying, engage, explore, and excel in learning science. Till next time, learners, have a nice day.